All right, I'm going to get going with our training around musculoskeletal injuries lecture. And again, I will be recording this and posting this too. I've already put this lecture up on Blackboard. So I think this will be a pertinent talk to a lot of you because I know there was people have expressed interest in doing PT or OT. So this is just a basic groundwork for training around musculoskeletal injuries. And what I'm going to be talking about here is I'm not talking about going clinical. We're not actually doing any diagnoses. We're just talking about how do you train around injuries. Like if someone has nagging knee pain or where it's a non-specific injury, or someone has non-specific low back pain, what might you do to train around those injuries, or how can we modify exercises? So just as a refresher, when you do an assessment, one thing that you might see is that somebody experiences pain with a specific movement. So what you can do is you can change the exercise, you could modify the exercise, and if neither of those two things work to actually alleviate any pain, then you want to refer out to a professional. So let me ask you this. Let's imagine that somebody has flexion-based low back pain. So when they go into spinal flexion, that hurts their back. Of these two exercises, A and B, which one do you think would exacerbate the situation? You can just type it in the text box. They have flexion-based low back pain. So if they have flexion-based low back pain, which one do you think is going to cause issues, A or B? Go ahead, just type it in the text box. Give it a guess. Yeah, good. So with A, that person is actually going into flexion. So that might be something that is more problematic than something that's resisting flexion. Okay, now let's do another one. You have 3 different squat variations. So in this picture we have a front squat, a high bar back squat, and then we have a low bar back squat. Which one do you think is going to put more stress on the low back? We're going to say A, B, or C. So A is front squat, B high bar back squat, then C low bar back squat. Which one do you think is going to put more stress on the low back? Yeah, great. Really, really great. So if somebody has low back pain, which one would you want to probably avoid? Probably C. So what are the stages of progression in exercise design? And there's really, at least the strength and conditioning realm, personal training realm, physical therapy realm, there's all a crossover, because if somebody's injured, they need corrective and therapeutic exercises. They need to learn how to actually do movement patterns correctly in a way that's not going to hurt them again. And they need to build whole body and joint stability. So they also need mobility at certain joints as well. And once someone's built that up, then they're working on increasing their endurance. And then also after that, they're working on building their strength. So the last category, develop speed, power, and agility, that might mean coming back to a sport if you're an athlete. Maybe that's something that the general population isn't worried about. But when you think of the numbers 1 and 2, that's therapy. 3 and 4 is 3 is probably where therapy meets like personal training or strength and conditioning. And then 4 kind of falls into the realm of what maybe strength and conditioning coach, athletic trainer, or personal trainer might actually end up doing. So what we're going to do is we're going to learn the importance of training stress and how pain can relate to that training stress. We'll go to how to modify technique and exercises to reduce stress. We'll do a brief introduction to a biopsychosocial model of pain. And we'll learn how to design a trainable menu for a person in pain. This might carry over into Friday, so let's see how much we can get done, or Wednesday. Let's see how much we can get done here. So what is pain? Pain is distressing experience associated with actual or potential tissue damage with sensory, emotional, cognitive, and social components. So there's the interesting part about that is that, read that again, a distressing experience associated with actual or potential tissue damage. So people can actually experience pain without any tissue damage. And this is something that you'll see with someone that might have persistent low back pain. Maybe they have no real damage there, but they still have pain. What you'll probably run into more is actual pain caused by tissue damage. So here's an example of something that happened to me, and at least I could turn it into a learning experience. This was a while ago. Some of you probably have done something like this. You accidentally got your finger stuck in between a weight tree, and that hurt really, really bad. So what happens when you actually hurt yourself? So if I were to just touch my finger when that had happened, I would experience pain. So after somebody has experienced pain or some kind of painful incident happens, the threshold for stimuli to cause pain actually decreases. So let me give you a more example. So when a natural stimulus is applied, there is a range of stimulus intensities over which a stimulus is not painful. Okay, so imagine that you put your finger on or right above a stove, and it wasn't that hot. So, but then the temperature starts turning up. Eventually, you're going to get to a point where it's going to cause pain. But also now imagine if you actually burned your finger and then you put it towards a normally non-painful stimuli, so maybe like slight heat, that would actually end up causing pain. So once you're already in pain, the threshold for things that cause pain actually decrease. So here's a graphical example of that. So let's say before you actually had pain, and look up here where it says firing level. So there's a lot of room for activities before you actually would experience pain. But you have all probably experienced this before. Let's say that let's say you hurt your ankle or something like that. Now you have much less room for activities without those activities causing pain. So you might have experienced that before. Let's say you twist your ankle. Normally walking is non-problematic. But then once you've actually hurt yourself, walking hurts, and maybe the only thing that you can do that doesn't hurt would be maybe just standing. So there's always going to be a pain threshold. There's always going to be some kind of loading tolerance, which when exceeded will cause pain and then ultimately some kind of tissue damage. So here would be 4 different examples of lower body exercises. So maybe I have a slight low back pain, and doing a front squat doesn't bother me. Doing a more quad dominant trap bar deadlift doesn't bother me, but when I start to move into more of a hip dominant trap bar deadlift, then that starts to become problematic. And then let's say that I've not getting better, I'm still in pain. Then maybe some of these lower threshold activities might start to cause me pain. So likewise, maybe I could do this lift at 300 pounds without causing pain, but then once I get hurt, my pain threshold actually drops down and I can maybe only do 200 pounds before I experience pain in my low back. But I just want to add that pain's not just caused by mechanical stimulus. So pain is also caused by our perceptions of incidences. And a good example of that is imagine that you stubbed your toe, and that would obviously hurt really, really bad. But then imagine that you stubbed your toe, but then you looked up and there was a giant truck coming at you. You wouldn't experience pain in that situation because it's going to be context specific. Okay? So pain is contextual. I'm not going to play these videos, but the lecture's up so you can go back and actually watch them. This one's a really interesting experiment. Maybe some of you have heard of it. Phantom limb pain. So there's people that actually are amputees that have pain in the areas where they used to have a limb. And in this case, they're doing a study, or not really a study, just an experiment, or they're making somebody imagine that they have another limb by using mirrors. And then they actually smash a hammer on the fake limb and the people feel it. It's pretty interesting. So, all right, so my graphics aren't necessarily going to work on this, which is what I thought might happen. So what do you want to do? We want to manage training stress. So how as like a coach can we manage training stress? So picture this. You have somebody that's coming in that you're going to be training, and this is the amount of training stress that you're going to provide them. Okay, so your exercise is going to fill up their training cup. Okay, so this is how much you're filling up with the training stress. This is what your plan is. But somebody comes in and they didn't get a lot of sleep, they had a lot of stress at work, and maybe they didn't eat that much that day. So they've actually already experienced quite a bit of stress that day. If you provided this much training stress to that person who only has this much left in their, let's say, metaphorical cup, that can lead to injury. So let's just say I had somebody that I wanted to plan a really tough strength training day, but they came in, they didn't really get a lot of sleep, their head's not really in the game, they're stressed at work. I can't apply that same exact training load to them. So again, everyone has a training load, which when exceeded can cause pain and then ultimately tissue damage. As people become more trained, their training capacity also increases. So take one person who's never trained before. The same amount of stress that you would apply to a trained individual, which would be non-problematic when applied to an untrained individual, can cause serious problems for that person. Likewise, you can increase the amount of stress your body can handle by training. So again, just imagine that if somebody has a lack of sleep, stress at work, didn't eat that much that day, and they're already in pain, you have very little room for the kind of training volume that you can provide for that person. So how do we manage training stress? So when I talk about this, torque is going to be very important. So torque just dictates how hard a muscle needs to work to overcome a specific load. So anytime that you are lifting, you're going to have what's called a muscle moment arm, which stands for MM right here. You're going to have, which is maybe one of the less important parts of this, you're going to have an external moment arm, which is, it says MR right here. So MR is the distance between the fulcrum, so where it's actually the movement's actually happening, and then where the resistance is. So FR stands for basically the force that's being applied. So in this case, if I was doing a curl, it would be the bar that I'm holding. And then FM right here just means the muscle, or how much force the muscle has to produce to overcome the load. So imagine that this arm got a lot longer. That would increase the external moment arm. So if the external moment arm right here increased, would my muscles have to produce more or less force to overcome that load? You can type it in. If my external moment arm, where it says MR, got bigger, would my muscles have to produce more or less force? What do you think? Type it on in. Yeah, exactly. Really good. So for example, if you were just holding a weight out in that position, and let's say it was like 5 pounds, you could probably do that for a long period of time. But then imagine you were holding like a pool netting and at the end was a 5-pound weight. You wouldn't be able to hold that for that long. So as external moment arms get bigger, our muscles have to produce more force to overcome them. So in this case, if I was doing a curl, technically speaking, as I'm going up with this exercise, my external moment arms past this point are actually getting a little bit smaller. So that's why you could hold the weight at the top of a curl for much, much longer than you could at that 90-degree portion. Here's another video explaining torque, but I won't play it all. So what's happening, you can raise your hand and tell me what's happening to the external moment arms at the knee joint as somebody goes down and descends into a squat. What's happening at those joint at that knee joint? Is it getting smaller or is it getting bigger as somebody descends into a squat? What do you think? You can raise your hand and say it. Typing it works too. Yeah, go ahead, Britt. Yeah, good. So I'll leave you on the line here too. So can you see the double arrows right here? So this is where our external moment arm at our knee is. Imagine that there was also an arrow going back to the hips. Is the hip moment arm also getting bigger? Yeah, it's getting bigger too. So now you lift. So do you, what's your best squat? Yeah. No, like weight. You could lie. You could say like 300 pounds. Okay, so you did 185. So let's just say when you did that 185, where was the biggest struggle? At the bottom or standing up with it? Like just unracking it and stand. Yeah, at the bottom, exactly. Because your moment arms are much, much bigger here, so your muscles have to produce much more force to overcome it. If you can squat 185, you probably could have stood with 245 on your back without going down, without lowering it. So thank you for that. Thank you for being an example there. So does that make sense? As external moment arms get bigger, we have to produce more force to actually overcome the load. So you can modify exercises. So here would be an example of a stick figure of a much more knee dominant squat on the right side and a more hip dominant squat on the left side. So with the more knee dominant squat, we're putting more stress on our knee. With the more hip dominant squat, which this one's actually kind of more neutral, we're putting a little bit more stress on our hips. So what we can do is we can take the same exact kind of style of exercise, so these are all still squat examples, and change the biomechanics of it to alter where training stress is actually happening. So someone has knee pain, maybe a low bar back squat where they're sitting back a little bit more. It was a little bit better for that person than a front squat if they have knee pain when the knee moves anteriorly. So based on that, how can we modify technique and exercises to actually reduce training stress? The first thing that I would always tell people is, so the outline is this: blank doesn't hurt the way you do blank hurts. So raise your hand if you've ever heard somebody say deadlifts hurt my back. Raise your hand if you've ever heard someone say deadlifts hurt my back. Yeah, good. So that might, and okay, and then for those of you that raised your hand, when you hear somebody say deadlifts hurt my back, and then you see them do a deadlift, does that explain everything? Raise your hand. Yep. So I kind of like a technique is so important for making sure that nobody gets hurt. So blank doesn't hurt the way you do blank hurts. So it's not deadlifting doesn't hurt the way you do deadlifts hurts. So technique's really, really imperative. The whole point of good technique is to protect your joints. So that's kind of always the first thing. If someone's like, oh, squats hurt me, and then I watch them do a squat and their feet are rolling in, their knees are basically touching, okay, that makes sense. Or maybe they're just going way too heavy and not owning that entire range of motion. So blank doesn't hurt the way you do blank hurts. So these are all videos you can check out later, but here's an example. Let's say that there's 3 different variations of a trap bar deadlift. So let's just say this one's very like a quad dominant trap bar deadlift. I'm staying really, really upright. And then this one's kind of more of a traditional trap bar deadlift. And then this one's like a Romanian trap bar deadlift. So which one do you think places the most stress on the low back? Raise your hand. Or actually, we can keep typing it in. Let's just say most stress in the low back. Is it A, which is the one in the top left corner, B, middle one, or C, one on the lower right? Which one's going to place the most stress in the low back? Good. Okay. Which one? That was all really good. You all got it correct. Which one do you think is going to place the least amount of stress on the low back? A, B, or C? Yeah. No, I would completely agree with that. Good. So we'll do the same thing with a squat variation. So when we do this, which one do you think places the most stress in the low back? We'll still say A, B, and C. So we have front squat, heels elevated, regular squat, low bar, back squat. Which one's going to place the most stress in the low back? Yeah. Which one do you think is going to place the most stress on the knee joints? Yeah, it's probably going to be A. Again, that's all going to be individualized too. But for the most part, it's probably going to be A. So now we'll do it. So you can modify a lot of different exercises to put less stress on the person's body. Like let's say someone can't do a bench press. Okay, can they do a floor press without that causing any pain? Can I do a partial range of motion bench press without causing any pain? So we change the angles of exercises, and we can also change the range of motion to reduce stress in certain areas. Okay, so brief introductions to the biopsychosocial model of pain. Basically, what you're going to get out of this is that pain is complex. So pain 100% has biological components to it. Okay, so that is like you actually damaged your tissue, and then that causes pain. There's also psychological components to it. So there's like, what is your belief? I bet we all know people that catastrophize pain. And then I bet we all know people that just think of pain as a regular part of life. And then there's also social aspects to it too. So one is like stress. How does stress exacerbate that? Something that I find really, really interesting is that when people are actually put on disability for having chronic pain, they're much less likely to go off of disability, because we actually have a situation where they're being monetarily rewarded for being in pain. Not saying that that's everybody, but there is research that supports that if people go on disability for chronic pain and get paid, they're less likely to go off of it. So I'm going to guess that all of you have probably heard of the placebo effect. And so that's when an inert substance actually has positive benefits. So for example, if you had a headache and I gave you a sugar pill and I said it was aspirin, the placebo effect would say that you're going to actually feel better once you do that, once you take that. Has anyone heard of the nocebo effect? All right, so then Mary has not. Thank you for your honesty, Mary. So the nocebo effect is very, very similar to the placebo effect. So placebo effect is an inert substance that doesn't actually do anything, causing positive benefits or having positive effects. So a nocebo effect is, again, it's a harmless thing that causes harm. So that would be like if I gave you a sugar pill and I said, this sugar pill is going to give you a headache, and then you got a headache. So it's an inert substance that causes harm versus placebo effect is an inert substance that causes benefits. So a nocebo effect can actually be words. So if you tell people things like this, and I'm sure you've all heard this before too, like if someone's saying, oh, you'll throw out your back or you'll throw out your knees, you're imbalanced, you have bad posture, it's going to cause you pain. So words like this can cause one, especially like movement avoidance. And if people fear movement, they have fear associated with movement, they're more likely to actually experience pain. So I think one of the biggest things you can do if you're going to be a trainer, if you're going to be a PT, an OT, is make people feel safe and don't make them feel like they're broken. So I like this chart. Imagine two people. One person actually does have a pain experience, and they don't have fear around it. They recognize that it's just a normal part of being physically active. They do all the right things, and then they recover. But then let's take another person. They have a pain experience, and then what happens is they're catastrophizing it, and so they avoid movements, which leads to disuse, which leads to greater pain experience. So I like this metaphor too. Knowledge about pain is really, really important. So imagine that you feel pain, something happens and you hurt yourself. One person reacts like this. Let's just say that, imagine that you hear a knock at your door. So that's a stimulus. On one hand, one person responds to it like it's a burglar breaking in. They're overreacting to that pain. Versus another person's like, oh, it's just a pizza guy at the door. So they're reacting in a completely different way to the same stimulus. So knock at the door, person who thinks it's a burglar is being catastrophizing it, and then someone who thinks it's just pizza guy at the door is having a normal reaction to pain. So how do we design a trainable menu for a person that actually has pain? So first, as I've kind of already demonstrated, there's a variety of ways to do the same exercise. So there's a lot of different ways that you can do a squat. There's a lot of different ways that you can do a deadlift. One of the main things I'd like to express is to work around pain, not through pain. And think about different ways to train the same muscle groups. So you can start with low back pain. So what's the actual definition of low back pain? So one, low back pain is probably the most complex form of pain, and it says an individualized etiology, which means it can come from a number of different reasons. So pain and low back pain is pain and discomfort localized below the costal margin and above the inferior gluteal folds, with or without leg pain. So that's the definition of low back pain. And low back pain can be non-specific or specific. So non-specific would be we're not sure why it actually started, and specific might be something like, oh, I was playing football and I got tackled and that's how I hurt my back. So what are the recommendations for somebody that has low back pain? So exercise is going to be more effective than rest. It's recommended they do resistance training 1 to 2 times per week, light to moderate intensities, and 1 set per exercise of 8 to 12 reps. So if I ever had somebody that I was training that had low back pain, I would always much rather have them come back 2 days later and just say, yeah, that wasn't that tough of a workout than having them come back and being in a lot of pain from it. So if someone has low back pain, I try to always undershoot the training volume until I know how much stress they can handle. So that means we're managing stress on the low back. Another thing that we can do is we can try unilateral exercises, especially if we're working the lower body. Unilateral exercises like lunges or Bulgarian split squats are going to put a lot less stress on the low back. The other thing that we're going to do is we're going to avoid end ranges of motion that might cause issues. So if somebody goes into flexion at the bottom of a squat, we want to actually avoid that, especially if flexion is what's causing them pain. So what are the best exercises to train the lower body around low back pain? I think that these are some really, really great options. Lunges and lunge variations, again, because they're not really putting that much stress on the low back. We're doing things like rear leg elevated squats. And I also think sled exercises are going to be great too, because you have really no spinal loading in those instances. All right, so then you can just check out the PowerPoint too. I don't think I can actually play videos off Blackboard Collaborate Ultra, but here are just some examples of exercises that you might end up doing. That one was a back pedal. This one's a push. Here's a quad exercise using a sled as well. And then just again, single leg training. So especially no matter what, if you put a bar on somebody, whether it's on their back or on the front, they're gonna actually have some stress on the spine. Versus this right here, so like the single leg squat, Bulgarian split squat, it's gonna be much less stress. So what are some other single leg exercises that can be loaded that don't put a lot of stress on the spine? You guys had a whole single leg day. What do you think? What do you think of some exercises that might be beneficial that don't put too much stress on the spine? So you can type it in the text box. Try to be as specific as possible. You can even use any kind of lunge variation on there. Maybe any sled variation that I didn't put up right there. Yep, great, Pablo. Step ups. Yep, so that's going to be a good example. You can hold weight at the side so it's not really loading up the spine. Anything else? Yep, side lunges. Anything else? What else do we got? Give me 2 more. Anything on single leg? Did a whole day of this. It was our last day together.
Thank you for calling.
Yeah, you could do some kind of elevated lunge. Yep.
Sure, what's your date of birth?
Sure, single leg hop. All right. So, talk about knee pain. What would happen, like let's just say someone with knee pain when they go below 90 degrees on their squat. What would you do if that causes pain? How would you modify that? What might you do? Someone with knee pain, someone has knee pain when they go below 90 degrees on a squat. What might you do to modify that? Don? Is that a person now?
Do you have refills on these medications?
Yeah, so yeah, good, Amy. So Yeah, so all of those are you're going through viable options, which would be change the range of motion and then potentially change the biomechanics of the
So
actual
I'm
motion.
actually going to transfer you down to the
All
pharmacy
right,
so
what
you
about
can
someone with
get
knee
your
pain when their
medication
knee goes
so
past their toe
is
on
it
a
available to
lunge?
you or be ready for
Let's say
pickup?
they're doing a forward lunge, knee goes past their toe, that causes them pain. What might you do? How might you modify that?
Okay, just stay on the line for me. I'm going to transfer you to the pharmacy.
Yeah, great answer, Amy. So you might end up doing like a reverse lunge. Good. So here's some pretty knee-friendly lower body exercises. One, generally speaking, Romanian deadlifts and Romanian deadlift variations. Those are all going to be pretty knee-friendly variations. Reverse lunges, which Amy just said. Trap bar deadlifts, especially when we're pushing our hips back a little bit more. Partial range of motion squats, which you just mentioned before too. And then sled exercises are pretty knee friendly as well. Okay, what about shoulder pain? So I put this up here because I wanted to show you how posture may actually interact with a person's specific range of motion that they have accessible to them, and then also pain that might be caused. So do this, like sit as upright as you can and then put your hands all the way over your head and then reach over your head, and probably most of you can do that with no problem, right? So now go ahead and slouch over like that guy in that picture and try to put your hands over your head so your fingers are pointing up right towards the ceiling. What happens? Stiffness. Yeah, are you able to reach all the way over your head, Pablo? Wow, you're very mobile. I can't do that. When you lean forward like that, you're able to put your hands all the way over your head, touch it with your fingers pointing towards the ceiling. Yeah. So if somebody comes in and they do have, so let's just say that it's thoracic kyphosis, which is flexion of the upper back, that's going to influence the mechanics with which. So if you can see the image of the scapula right here, when somebody reaches overhead, their scapula upwardly rotates. So not you can't. I don't even know if you can see my arrow, but the bottom of the scapula starts moving upwards, and that contributes to about a third of the overhead range of motion that somebody has. And then also the humerus contributes to the other 2/3, so going overhead. So if you have issues going overhead, because of for whatever reason, maybe you have that thoracic kyphosis, and you try to keep going overhead, eventually you're going to start to see things getting pinched right in there at that joint. So you might have things like your rotator cuff muscles getting pinched. So here would just be an example of somebody that I train, and he's just lying down on his back. And I just want to see how far can he get his hands over his head. Um, so can you clearly see with this person? So he does have a history of injury, but what can you see? Yeah, limited range of motion, and then can you see a difference between left and right side on the top picture? Yeah, so he's got limited range of motion, particularly on his left side. Yep. And so even after we did some things, and it can improve once he gets going. So you can do some kind of corrective exercises in our warm ups to make it a little bit better. You can see on the bottom that it's a little bit better, but what compensation can you see from this person on the bottom picture? So his range of motion looks a little bit better. But what compensation can you see? Yeah, so his back is very extended, so he doesn't have that range of motion, so he's making it up somewhere else. Okay. So this is important too. Like let's say someone has limited shoulder range of motion, and it looks all well and good when they're doing overhead presses, but they're actually really, really arching and extending at their low back. That could cause problems at the low back, especially if they're going pretty heavy. So when I think about this and I look at this, I'm like, okay, maybe I can improve it a little bit, But what is going to be off this person's trainable menu? Are overhead presses on his trainable menu? Considering he has pain, he can't attain that. Yeah, so he can't attain that range of motion. He has pain. So I need to think about something else that I can do to actually train him pain free. And so things like this, if people have shoulder pain, a big culprit of exacerbating that pain is just called the high five position. So something like this is probably not going to be too shoulder friendly. Which bench press variation, if somebody has shoulder pain, do you think it's going to exacerbate it more? Left or right side? Left or right side? Which one do you think is going to exacerbate pain a little bit more? Yeah, great. So you're basically in that high five position. So if somebody's benching, so again, it kind of goes back to the bench pressing doesn't cause pain. It's how you bench press that causes pain. So if someone's benching like this, we might want to encourage them to have a more elbows in, arched back position. So what are some more shoulder friendly pressing exercises? So especially with that person, he can still do low incline presses. So we're not going all the way overhead. We can do angled barbell presses, so that's like a landmine press. Some of you might have seen that one before. So if you can't go all the way overhead, there's always different variations that you can work on to do things. Another thing that we can do is we can change the mechanics of the exercise. So has anyone ever done this exercise? It's a side lying lat raise. Yeah, okay, so let's just say you're standing up and you're doing not this one. So let's say you're standing up and you're doing a lateral raise. Where's the hardest part of the exercise? At the bottom, middle, or top? Yeah, at the top, exactly. So at the top of the range of motion is where it's going to be the most challenging. Okay, so let's say that somebody has shoulder pain when their arm is at 90 degrees. Okay, well then the standing lat raise might not be a great idea for that person. Okay, so what if I'm doing this side lying lat raise? Where's the hardest part of the range of motion? The bottom, the middle, or the top? We can just say, actually, where's the least challenging part of this range of motion? Where's the least challenging part? Let's do that. Yep, so when we do the side lying lat raise, where the position that my arm is in right now is actually the easiest part of the range of motion. Okay? So the bottom and to the middle is going to be the hardest part. So all I've done is I've changed the mechanics of the exercise. So now right down there at the bottom, if my arm was on my leg, that would be where the hardest part would actually be. If I decline that even more, it might be even more challenging. So right here at the top of that range of motion, there shouldn't be that much stress. So you could probably hold that right here for a much more prolonged period of time than you could in the middle. Okay? Because there's less stress. Okay, so now let's say that somebody has, we'll do this. Somebody has shoulder pain when they back squat. So when you back squat, you're essentially putting yourself in that high five position. Okay, so you got your arms back, just like how kind of similar to what you do for that overhead press position. So let's say that bothers somebody. What's a squat alternative? So let's say bilateral squat alternative for somebody that has shoulder pain when they do a back squat. What is an example? Goblet squat, great. So we change where the arms are. What else? There's a few. Goblet squat. What else is similar to a goblet squat? Yeah, Zercher squat. So again, yeah, we're front loading. What else? Safety bar. Safety bar squat is going to be really, really good for somebody that might have shoulder pain. All right, so we'll just wrap this up. Guess we won't go into the next time. So one, pain is multifactorial. So of course there is a training stress component, and I think when we're talking about training stress, that is one of the two best ways that you can help somebody actually manage pain and work around pain. The other one is your language matters. don't make people feel like they're actually broken. So I think that one of the worst things you can do when you're coaching somebody is tell them everything that's wrong with them, because that can make them one movement avoidant, and that can have them associate fear with movement. So we really want to avoid that at all costs. Think nocebo effect. Your words technically are an inert substance, but they can cause harm. Um, Also, you can modify exercises. So we've given different examples of how can we modify exercises to reduce training stress in certain areas. And then the last one, which I think is really important, is to know when to refer out if you actually need to refer out. All right, I'm going to pause the recording.